original expression. Original expression is always P implies Q. So in this theory, the P is study regularly. That means if the student study regularly, this is your P. If the student study regularly, this is your P. And then, that is the result, then he will pass all exams. So this is your Q. So if you have P, you have Q already, and the original theory is P implies Q. So in direct method, that is first method, direct method system, you will show the thing in the same way. That is, you wait for somebody who studies regularly, maybe you yourself or maybe your younger brother or friend. Then you see he or she will attend the exam. Then you see he or she will pass the exams. Then you prove, then you show, okay, see, this is my friend and he studies regularly, then he go to the exam and pass all the exam. So this is the direct proof method. You understand what I'm saying? So this is the technique, this is the way you will show. Now you can tell me, okay, sir, how can I show this in the exam? Yes, in the exam, maybe I will not give you any question like this. In the exam, you cannot show this because you need to wait for somebody who is studying regularly at home. And you need to wait for that student who will attend the exam, and you need to wait for the result. So when the result will come, then you will say, yes, so this is the proof. Directly, I can show you that one person studies regularly, then he can pass the exam. Second method, how can you prove this thing by indirect method? So second method is actually, I already told you, second method is actually not Q implies, I already told you, not Q implies not P is a tautology. So this is the thing you will check. So what you check here, what you do here, you prove this theory for this example that someone will not pass. Someone will not pass. So you can say, okay, student does not pass exams. Okay, does not pass exams. Then you can write if here, no problem. If a student does not pass exams, then
He does not
he,
study regularly.
right, does not study. Or if you want to write he did not study, that is also all right, no problem. We are not talking about grammar. So the thing is, he does not study. So that means you wait for a result, and you see one student does not pass. Does not pass means fail. So then you ask him, okay, did you study, or so something like that. Okay, so this is how you uh, prove the theory in indirect method. So this is the second example. Third example is method of contradiction. I can do it tomorrow, but if we have time, we will show the example today also. So let me just tell this thing again briefly. It is P implies not Q. Is fallacy. Is false. Is always false. So in this case, what we will do for this example, we will pick up a student and we know that he or she studies regularly. So we already know that he studies regularly. because this is our P. This is our P. Okay, if a student studies regularly, this is our P, then we will see that he or she will not pass is always wrong. Okay, he or she will not pass is always wrong. Then he or she, okay, he or she does not pass, does not pass. This whole thing is always wrong, is always wrong. That is false. So you can say, okay, it is a fallacy. That means it is not possible. That means we can say that actually if a student studies regularly, then he passes. Then he passes. Because not pass is not possible. Not pass is not possible. So he will pass. This is how we uh, apply the things. And another method we will discuss, that is the induction method, and we will do it later. So let me uh, do some problem examples today. First, direct method.
Sir,
Yes.
could you repeat again, please? Direct method of proof.
Direct method means there is no change in the original theory. Original theory is always P implies Q, and in the direct method also, we will show that same P implies Q. There is no change like this. This is a change, not Q implies not P. This is a change. P implies not Q. But in the direct method, there is no change. Same theory, and it will be a tautology. So how can you show this directly? It is always true. It depends on the situation. It depends on the given problem. Okay. Say for example, this is the situation. So it is a social thing. You cannot just calculate. Okay. You cannot show this by calculation 1 plus 2, 3 into 4. Not like that. This is a social thing, human thing. You need to show this. You need to see the thing by waiting. Okay, you need to see someone is reading and writing and then giving exam and then passing. Then you can show, okay, so this is happening. If you want to show something like about trees, so if you see, okay, mango tree will give you mango always. Do you think it is a correct theory?
Yes, sir.
Mango tree will give you mangoes. So this is a theory. Okay, so how can you prove this? You have to wait for the mango tree. You have to wait. There will be a mango tree. It will grow big, and then there will be fruit, and then you will say, okay, see, this is a mango. So it is the direct proof method. You understand? You cannot just calculate something on your khata and you can show, yes, a mango tree will give you mango always. So the theory, the situation may be different, and maybe you will show this in many different ways. But the technology, the logic, the theory, you need to understand how we do that. Okay, so now let me start some of the examples here, then you will understand one by one. So for the direct proof method, I am writing some question like proof by using the direct method that, okay, so there is a theory given. What is the theory? The theory is like if n is an odd number, then n square is also odd. Okay, so this is one question. Okay, the question maybe say it is question number 1, and this is square. The last n is square. So I will write the square, don't worry. Okay, so okay, let me write it first. This is actually square. So the question is, if n is odd number, then n square is also odd. So it is a theory, and you prove this. Oh, sorry, this is not verb. The verb is prove. The verb is prove. So if you prove this by using direct proof method, then how you do this, how you will handle this, that is the question. So let me give some more questions, and another direct proof question. Okay, so I'm writing question 2. By direct proof method, show that square of an even number is, oh no, এটা তো একই হয়ে গেল. Let me let me give you another type of thing. What I can give you. Say 2n plus 1 is an odd number for any natural number n. Is that okay? You can see the question? Okay, so I'm just making this question right now. And then two more question indirect. Okay, let us do it one by one. So think about the first question. First question is, the theory is given here. If n is an odd number, then n square is also odd. This is a question. So what is your p? You try to identify what is your p. So n is an odd number. This is your p first, and n square is also odd. So that is your q. Now you do not need to write pq. You do not need to write pq. Just think and try to understand. Keep it in your brain. That will be fine. So you use the direct proof method. That means you do not change pq. The theory is p implies q, so you just keep it like that. So you start with p. Because the p is the fact given in the theory, and you have the same thing here. You will also use the same thing. So by the direct proof method, you start with p, the same thing. Direct proof method. Okay, we have what we have, n is an odd number. So we can write n is an odd number. N is odd. So n is odd means say n equal to something like this, 2k minus 1 for all k belongs to n. Is that okay? Can I write this? So you will understand for any natural number, if you take k as natural number, 2k minus 1 will be the odd number. You can just think about what is k equal to 1, then find out n. If you put k equal to 2, then find out n, k equal to 3, find out n. So you can just check with the numbers like that, and then you see what are the numbers coming. Definitely all will be odd numbers because this is the pattern of odd. And for even number, the pattern will be 2k, like that. Okay, so odd pattern is generally like 2k minus 1, and sometimes you can also write 2k plus 1, that is also correct, but we start or we write like 2k minus 1 because the natural number starts with 1. So if you put k equal to 1, then it will be 2 into 1 minus 1. So 1 is coming. So this is the starting point. So that is why we normally use 2k minus 1. So this is all right. And then it is n. So we need what? We need n square. We need n square. So you write n square. So then check what happens with n square. So you already have n, and then you checking the n square, that is 2k minus 1 whole square, and then you just expand the whole square thing. So it is 4k square minus 4k plus 1. And what do you think? It is 2 bracket 2k square minus 1, right? Or minus 2k, right? And then plus 1. So what do you say about this? What you can say about this is 2 into something. I mean, the first part is 2, then into something. So 2 into what? We do not need to care. 2 into whatever, 2 into 1, 2 into 3, 2 into 4, 2 into 7, whatever. It will be even. Okay. And then when you have plus 1, then it will be odd number. Isn't it? So you can write this is always odd, because 2 into something is even, then plus 1, it will be all together, finally it will be odd number, always odd. So you can see, okay, if n is odd number, then n square is also odd number, and you are proving this directly. So this way the given theory is, okay, you can say the given theory uh, is proved. Given theory is proved by using direct proof method. Given theory is proved, okay, by direct method. So this is how you do the calculation or do the problem. Is that okay? Do you understand now? Any question, or
Uh,
this is all right?
no, sir. It's
Sir,
okay.
sir, all right.
Okay.
Sir,
Then
second line
yes.
here in equal 2k minus 1.
Hmm.
You say this is odd, and our answer n square 2 into something plus 1. Here has change plus and minus. So all time plus and minus, we add or subtract 1, all is odd.
I'm not sure what you are talking about. This plus
Sir,
1 is coming from the formula, a minus b whole square formula. and this one is the general form of odd number. So even number will be generally 2k, odd number will be generally 2k minus 1. So we start like this, and when we expand a minus b whole square, then this plus is coming. Okay, now what is your question?
স্যার মাইনাস ওয়ানটা কি করে পাইলাম স্যার?
Minus 1, I already told you, minus 2k minus 1 we take as the general form of odd number. This is the general form. Every time if you write 2k minus 1, that will be odd number. So you can try with this. You have to understand this. I mean, not only 2k minus 1. 2k minus 1 for all k implies natural number. This has to be included. If you do not write this, then it is not accepted. 2k minus 1 you can write if you write k implies, or k is a member of natural number set. So if you think about natural number set, what is the natural number set? That is 1, 2, 3, 4, like all the whole numbers. And if you think about any number in this set, you can put 1 equal to k, you can put 2 equal to k, you can put 3 equal to k, you can put 4 equal to k. Any number you can put here, then this n will be always odd number.
ওকে স্যার, ওকে স্যার।
So that is the thing. Now let me show you the proof for second. So about second, again you check the theory. So you check the theory. I have written questions in different way. Okay, the language is different. First one is prove by using direct method, and second one is by direct method, show that this. So what is the theory here? So this is the theory. 2n minus 1 is odd for any natural number, and this is the theory. Now, if it is the theory, what is your P? What is your Q? You have to find it out clearly. If you make mistake, then your whole proof will be mistake. All question will be, answer will be mistake. So what do you think? What is your P in this case? This is the theory. So what is your P and what is your Q? Think and find it out.
Sir, any natural number is P, 2n plus 1 is odd is Q.
Okay, good. It is correct actually. Any natural number n is P. That means if you think this is your P, then the idea will match. So actually they are giving you the theory, like actually the theory they have given here is it is not written. I'm just writing for your understanding. This is not the part of answer. The theory is given like if n is natural number, okay, if n is natural number, then 2n plus 1 is odd. So this is the theory actually given in the question. Okay, for any natural number means n has to be natural number first, and then as a result 2n plus 1 will be odd. So this part is P, n natural number is P, and 2n plus 1 is odd. This is your Q. So if you understand what is your P, what is your Q, then you can go for proving the theory. And in the direct proof method, actually you do not change the order. You do not change what is P, what is Q. Just say same thing you take. So what is your P given? n is a natural number. So you start with this. P is the fact. Q is the conclusion. So you start with P. So you can write, okay, uh, here we have, okay, n is a member of natural number set. So we can think, uh, so we consider, okay, we consider n is either even or odd. Okay, n is a member in the natural number, so definitely it may be even number or odd number. What else possible? Nothing else possible, because there is no fraction. So irrational, rational, those type of things will not be considered here. Only either odd number or even number. What about zero? If n equal to zero, so is it included here? Is it included this either even or odd, or it is out of the consideration? What do you think? Do you have any idea? Zero is odd number or even number?
Sir, 0 is not even, 0 is not odd. It actually দশকীয় মান নির্দেশ করে স্যার।
Okay, so that is why I'm asking. So you need to think either even or odd or zero. Like that? Do you think like that? There is another possibility that may be zero also. Everyone agrees with this?
Yes, sir.
Or do you think even odd is okay? Fine. There are two types.
No, sir. Zero is not even or odd, so
Should be.
yeah,
So you
consider
think,
zero.
you also think, okay, you also think that there should be three types, three categories: one odd, one even, one zero.
Sir,
So
zero also
everyone
is not a natural number, so we can actually exclude that. I think in that way.
Right, good point. Good point. So zero is not a natural number. So why should you think about that? No need to think about that, right? So this is a good point. Zero is not included in n. Zero is not included in n. You are right. So zero is not included in n. So you need do not need zero. Okay. So either even, either odd is fine. Good. There is no problem. But you should know that zero is even number. Okay, zero is even number. Zero is even number. You should know. It is not necessary here because it is not included in natural number set, but zero is even. Okay, just know this. It is important. Sometimes maybe it will be necessary. So zero is even number. How zero is even number? How can you say it is even number? If I now give you a theory, zero is even number, and prove it by direct method, then how can you prove this directly?
0 divided 2 is 0.
Yes, correct. So what is the definition of even number? If a number can be divided by 2 and the remainder will be 0, so that will be even number. You can think, okay, 0 mod 2. If you do this calculation, 0 mod 2, so what will be the answer? Isn't it 0?
Yes, sir.
So mod 2 means you are dividing by 2 and 0 means the remainder. So if 6 mod 2 is 0, then you will say yes, 6 is an odd number. If you see 5 mod 2 is not 0 actually. 5 mod 2 is 1. So you will say no, it is not even number. So in this case 0 mod 2 is 0. So it is even number. So let us go back to the question number 2. So now the thing is, you do not need to include or think about 0 because it is not in the natural number set. Even if you think or if you need to take natural number, I mean 0 in the set, in that case also 0 is included here in even number. Okay, fine. So we will consider two things. Now, when it is even. So when means, say when n is even. We are now thinking about one possibility. So n can be written as 2k, like that, 2k. So what is k? K can be any number, any natural number, any, even you can think any integer. So in this case we are not talking about integer, so it is natural number. So this is the situation. So what will be 2n plus 1? What will be q? What will be q? Now we will check what will be my q. So q means 2n plus 1 is odd. So 2n plus 1 in this case, it will be 2 into 2k plus 1. So it is 4k plus 1. What do you think about 4k plus 1? It is also odd number. It is also odd number, always odd number. Because 4k is even and then plus 1 is always odd. So it is proved. Okay. So this is correct. Now you check with the other possibility, other option also. When n is odd. So when n is odd, you take n equal to 2k minus 1, and for all k in the natural number set. So now you check with the q, that is right side. So it is 2n plus 1 given, and then you are putting the n value as 2k minus 1. So 2 into 2k minus 1, then plus 1 in the expression given. So we are getting, it is 4k minus 1 into 2, that means minus 2, and then plus 1, so minus 1. Isn't it? 4k minus 1 finally. So don't you think it is also odd? Yes, it is always odd. It is always odd. So you can say it is also always odd number. Now you finally conclude that the given theory is correct. So given theory is proved. Proved means it is correct. Proved means we have shown that it is true. So you can write, okay, so given theory is correct. Therefore, the theory is proved, okay, by direct method. So this is how we do the calculation. Now let me show you, we do not have enough time, but we need to show at least one problem by using the indirect method. Okay, so let me just do this here. I mean, maybe the okay, let me take another example, then I will show you some similar problem in the next class. So let me take another example. I'm just writing the question again. It is question number 3. It is question number 3. So I'm writing by using the indirect method. prove that if 3n plus 2 is odd, then n is odd. So this is just small kind of things we are showing. Maybe some other a little complicated questions we can do. Let me just write another question. I'm not sure I can do this today or not. So the question is by indirect method of proof, show that if for any integer n cube plus 5, it is n cube. I will write n cube. Okay, n cube plus 5 is an odd number, then n is an even number. So this is another question, and it is n cube plus 5, and that one is 3 into n plus 1. Okay, so this is the question given. I mean, two questions, and they want you to prove this by using the indirect method. So first thing, again in the same way, you will try to understand what is P, what is Q. For the question number 3, you try to find out what is P and what is Q. So answer for 3. So what is P here? P is very straight cut. It is given very straight. If, then, so you understand easily. This is your P, and n is odd. This is your Q. So it is very straight cut. The theory is P implies Q. So you follow the rule for indirect method. So what is the indirect method construction? What is the indirect method technique? That is, not Q implies not P. You will try to find this or prove this as a tautology. So you will prove this as a tautology. So this is the construction. You do not need to write this, just keep it in your mind. So you start with the fact not Q. You start with the fact not Q. You understand my point? So by the indirect method, you start with not Q. So what is your P, what is your Q? You do not need to write it in the answer. You understand, you keep it in your brain, and then you start with not Q. So by the indirect method, we consider here, you consider what we consider, n is not odd. Okay, n is not an odd number. So if n is not an odd number, that means we are considering not Q. Okay, so that is n equal to even number, and n will be like 2k, right? You can write it here, n equal to 2k for any k, in the integer also you can write, no problem, or you can write natural, no problem. There is no boundary given. So it's fine. Now you go to the next part. What will happen? What will happen with the next thing? Is it not P or not Q? What is happen? So you take 3n plus 2. Then you check. Okay. Now you take 3n plus 2. What happens with this? If n is 2k, that means 3 into 2k. So 3 into 2k plus 2, so it means 6k plus 2. So you can take 2 as common, so it will be 3k plus 1. And what do you understand by this? Is this an even number? Yes, it is always an even number because it is 2 into something. So if it is 2 into something, then it is even number. And if it is even, then it is not odd. So not P is coming. You understand my point? That means what? Always even. That means what? That means 3n plus 2 is not even. Sorry, not odd. It is even means not odd number. So if it is not odd number, that means it is not P. So what you started with? You started with not Q. Actually, you started with not Q. So this is your not Q. You started with not Q and you are coming to the decision. You started with not Q and you starting with the decision that it is not P. So it is not P. So not Q implies not P. You are getting not Q implies not P means indirect method is used and you are proving the theory. So just now you write a conclusion, write a concluding remark. You will write the theory is actually proved correctly. The theory is proved, okay, by using by the indirect method. So this is how we solve this, or this is how we do this. Now you can try the question number 4 at home, and if there is problem, I will do it in class tomorrow, and I will also do some other examples with contradiction method also. So maybe tomorrow we cannot finish everything. Maybe we need another class for induction method also. So tomorrow I will finish the direct indirect contradiction, and then in the next class I will show you the induction method. So that's it for today. So do you understand this?
Yes, sir.
Yes, sir.
Okay, so that